Hello from Slide Nerd and hello from Weeps. What's up, folks? In this video, I'm going to talk about how to measure user interface elements using device independent pixels and how to use fonts inside your Android apps using scaled pixels. Now, if you guys are beginners, you probably looked at these two terms and you wondered what they meant, and you also had the question that why I should not use pixels to measure stuff in Android. And in this video, I'm going to explain the details behind why you should not use pixels. The first question that arises in your mind is, what is screen size? This is a very simple question, but in Android it is easily misunderstood if you're a beginner. So here, their physical size measured along the diagonal is the screen size. Now there are four of them: small, normal, large and extra large. So here in the diagram, if you see you have a mobile or you have a tab or whatever, you have to measure the length of the screen along the diagonal, and that is what the screen size is all about. Same way, you have screen density as the next concept, which we're gonna see here. Number of pixels in an inch is known as dots per inch or pixels per inch, PPI or DPI. Now there are four main categories: low density, medium density, high density and extra high density. Now remember one thing, every Android device has a different density. They just fall broadly into these main four categories. So for example, now what is the difference? Here is the difference. If you have 1 inch on a low density, you probably have 10 points over here, probably have around 20 points in the medium density, and you have somewhere around say 30 points in the high density. So if you're making an app and you use pixels as the base unit, the problem is this will be 10 pixels perfectly on LDPI, this will be half the screen on MDPI, because 10 will be only this many squares, right? And here 10 squares will be just 1/4. So the problem is the same user interface element is going to look different sized on different screens with different densities, right? So we don't want that to happen. Again, here there's another chart. So whenever you give units in DP or device independent pixels, what happens is for an LDPI it is multiplied with 0.75 to give you the actual pixels. For an MDPI it is multiplied by 1, for HDPI it's multiplied by 1.5, and for XHDPI it's multiplied by 2.0. Remember, what the Android developers want you to do is to specify the size in device independent pixels. Now these device independent pixels or DPs, they will be multiplied with one of these values for the appropriate device, and that way you don't have to worry about how big it is going to look on different screens with different densities. And that is the best part about why screen density matters in Android devices. Again, screen orientation, it's a very simple thing. Aspect ratio, you guys are very well familiar with this. I've talked about this in detail earlier. There are two modes: portrait, landscape. Screen resolution, again, you have the number of pixels on the screen. That's all about screen resolution. Remember one thing very important in Android, you're not concerned with screen resolution mostly. You do not work with screen resolution because it varies heavily. Remember, there are many devices out there and each device has a different screen resolution. So if you start working with screen resolution in your app, if you start designing stuff, buttons, text views for screen resolution of a particular device, then you're screwed. So don't work with screen resolution and work only with the screen size and screen density. Now if you guys remember, there were four categories in the screen size and there were four categories in the screen density. Now you will use those categories as resource qualifiers when you make layouts or you make user interface controls or resources, right? Now I'm going to talk about resources in detail further, but for now all you need to understand is Android offers you a way to categorize your user interface for different devices. Remember that. Now you have your Android user interface measurement units: millimeters, inches, points, DP and SP. Out of these five, only the last two actually matter. Millimeters, inches, points, they are all fixed physical sizes. You're not supposed to use them. Use DP. Now remember, as I said, for DP you have low density, medium density, high density, and of course there is extra high density, right? So the first question right now at this point you guys probably have is, what is a device density independent pixel or device independent pixel? Remember, it is called with both names a virtual pixel, where you can define your dimensions, right? So here what you want to do is you want to say 100 dp and you don't want to worry about how big it looks on different devices. You want Android to take care of how big or how properly it should look across all the devices, right? So system converts the dp into pixels whenever your app runs, all right? So for that, this is the conversion that the system uses. It calculates the pixels out of your specified dp by multiplying that with dots per inch on your device and dividing that by 160. Now let me talk about this. When you have an LDPI device, what happens is, if you say 100 dp, it's going to be 100 into 120, that is the dots per inch on your device, divided by 160. For 160 dpi, you can easily see that the number of pixels and the number of dps are going to match, right? And for an HDPI, it's going to be 1.5 times. For an XHDPI, it's going to be 2 times. So in short, if you see these two different devices, this is the benefit of doing this. Here, if you see, this is 148 dpi or ppi, and here this is 208 ppi or dpi. Look at the user interface, look at this controls over here, they look the same size on both the devices, and that is because you have specified the units in terms of device independent pixels. So when you run on different devices, Android is going to automatically apply the scaling factor to that particular device and make sure that the size of the user interface control is proportionate to the size of the screen. So you guys are getting the point now, I believe. Now what do you get with density independent pixels? Again, just to give you guys a rough example of what happens without density independent pixels and what happens with them, take a look nicely over here. This is right from developer.android.com. You have a low density over here. This here, if you see, you'll notice something weird. There's a button, there's an image view probably, right? And it looks different on different screens, right? Here on a high density, this looks smaller. On a medium density, a little bigger. On a low density, very high, right? What happens is the user has probably specified the size in terms of pixels. If you say 100 pixels, that is fine here on a low density device, right? But on a medium density, remember, there are more pixels per inch. That means if you say 100, it is going to fit in a smaller area. If you say 100 in the high density, there are further more pixels per inch, and this is going to fit even in a more smaller area, right? But if you see with the device independent pixels, what happens is when you say 100 dp, 100 dp is multiplied by something to give you pixels. Here 100 dp on the medium density is multiplied by something to give you pixels. So in short, Android takes care of maintaining that proportion between the screen size and your user interface component size, and that is why you should use device independent pixels. Remember, device independence or density independence means preserve the physical size of your UI across different devices with different screen densities. So next, what are scaled pixels? You guys probably have another question like this, right? Now scaled pixels is the same concept, but it is for only fonts, right? You don't use it for anything else, you use only for fonts. A virtual pixel scaled according to the density and user font preferences, remember. So whenever you're using fonts, you want to make sure that again fonts are in the same proportion across different screen sizes for different devices with different screen densities. So to make sure that happens properly, you use scaled pixels in the unit. And here, as you guys can see, it's 12sp, 14sp, 18sp and 22sp. So the conclusion from my side is this, that you guys don't use pixels, only use device independent pixels and scaled pixels. Use device independent pixels when you're talking about normal sizes like dimensions, then you're talking about how wide the button should be, text view should be and so on. But use SP or scaled pixels when you're talking about fonts inside your app. So I hope you guys have understood something out of this vid. If you like what you saw, please subscribe to my channel, comment, let me know your thoughts. I would love to hear from you guys. Thanks for watching. I'll catch you guys later. Have a nice day.